There are 4 men and 6 women in a work group. They must choose a total of 3 people to form a committee. How many ways can a committee form that has all men? There are 4 men. We're picking 3 people. That's just going to be 4, choose 3. Did I do the one before this? Yeah, okay. 2 women and 1 man. Okay, I'm going to pick 2 women from the group of women. That's 6, choose 2. Times 1 man. 4, choose 1. I forgot. This is going to be 4. 4, choose 3 is 4. 6, choose 2 is 15. 4, choose 1 is 4. So this is going to give me 60. What is the probability the committee will have all women? Well, the probability of all women is going to be, the bottom going to be the number of ways I can pick the committee. I'm picking 3 people from a group of 10. That's 10, choose 3, regardless of gender. The top's going to be, how many ways can I pick all women? 6, choose 3. Okay, so we have 6, math, choose 3. And then we do 10, math, choose 3. So 20 over 120. This is going to be 1 over 6. 14, how many ways can 8 books be arranged in order on a shelf that holds 4 books? Order matters. Holds 4 books. How many choices do I have for the first book? I have 8, 7 for the second, 6 for the third, 5 for the fourth. That's the same thing as saying 8 permute 4, which is 1680. Okay, how many ways can 5 people, A, B, C, D, E, sit in a row in a movie theater? A and B must sit on the end. So there's 2 possibilities. We have A in the front, B in the left-hand or right-hand side, and we have B on the left, and A on the right-hand side. So here we have 3 people left, C, D, and E. So there's 3 choices for the first, 2 for the second, 1 for the third. Same thing here, 3 choices, 2, 1. 6 ways this can be done. 6 ways this can be done. So the total number of ways this can be done is 12 ways. Okay. A 10 multiple choice test has 4 choices for each question. If you randomly guess the answer to each question, what's the probability you get at least 1? Okay, that's a hard problem because you have to figure the probability of 1 and 2 and 3 and 4 all the way up to 10. So let's just find the probability of none. Probability of none correct. And we'll subtract that from 1. So how many ways can I get the first question wrong? Well, 3 out of 4. There's 3 wrong answers, 1 right answer. How many ways can I get the second one wrong? 3 out of 4. Third one wrong, 3 out of 4. Last one, 3 out of 4. I'm doing this 10 times. So this is just going to be 3/4 to the 10th power. Okay, that's probably none correct. If I want at least 1, that's the only other possibility. So my probability is going to be 1 minus 3/4 to the 10th power. So, let's see here. I don't know if you want a decimal, it doesn't specify it. It's going to be an ugly number. 1 minus 3 divided by 4 to the 10th power. We'll just say 0.94366. 0.94387. Maybe list both this and this just so they see what you did. The first 6 correct, the last 4 incorrect. How many ways can I get the first 6 correct? Well, the probability, anyway. The first one correct, there's 1 out of 4 ways to do that. Second one correct, 1 out of 4 ways to do that. The 6th one correct, 1 out of 4 ways. I'm doing this 6 times. And then the last 4 incorrect. 3 out of 4 ways I can do that. 3 out of 4. 3 out of 4. 3 out of 4. So it's going to be 1/4. 1/4 to the 6th times 3/4 to the 4th. 1/4 6th times 3/4 Ooh, very, very, so I'm going to show you what that number is. It's going to be plus 1. So that's going to be 0.0000772. That's a very small probability. Then it says all incorrect. Well, there's only one way to get them all. Well, no, there's one way to get all incorrect. That's just going to be, we found the first one. 3 to the 4th, 3/4 to the 10th. 3, 3/4 to the 10th power. 0.05631. 0.05631. All right, 17. Suppose you have a spinner with 3 colors, red, blue, and yellow. Assuming that it's a fair spinner, what is the probability of landing on yellow? Well, there's 3 colors, so there's going to be 1/3. Assuming it's a fair spinner, after 10 spins, you have come up with 7 yellows and 3 blues. What is the true probability of landing on yellow space on your next spin? What is true about the probability of landing on yellow? Well, it's a fair spinner, so none of this matters. If it's a fair spinner, landing on yellow is about the same as landing on red or blue. It's not more or less likely because it's a fair spinner. It's a trick question. Is this 30? No. Okay. A group of college students were asked if they carried credit cards. The responses are listed on the table. If a student is chosen at random, what's probably that he or she is a freshman? That's the total number of freshmen over the total number of people. That's just going to be 53 over 90. Carried a credit card or was a freshman. So to find out the first group, let's do this. Come on. It's not working. So they carried a credit card, whatever, we'll do it this way. There's 35 people who carried a credit card. There's 53 people who are freshmen. We counted a group twice. We counted the freshmen who carry credit cards. So this 20 people was counted in both groups. They're part of this group and that group. So I have to subtract that. It's an OR probability. It's a probability of a credit card plus the probability of freshmen minus the probability of both. 35 plus 53 is 88. Minus 20 is 68. 68 over 90, which is 34 over 45. Did not carry a credit card given that he or she was a freshman. So we know they're a freshman. So I don't care about any of the other rows except for the top row. They do not carry a credit card. That's this group over the number of freshmen. 33 over 53. That doesn't reduce. 53 is prime. Okay. How many distinguishable ways can the letters of the word statistics be arranged? So you need a formula for that. I have the formula right here. It says permutations of duplicate items. The number of distinct permutations of n objects where there are identical is found by the formula. So n factorial is the total number of items. So we have how many items? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 factorial over all the duplicates. So we have, let's see here. We have how many s's? We have 2 s's, that's 2 factorial. Cross that out. We have 3 t's, that's 3 factorial. We have 2 i's, 2 factorial. And the rest, there's just 1 of, so we don't care about that. So it's 10 factorial over 2 times 2 factorial times 2 factorial times 2 factorial. So we get, let's do this math. It's alpha y, get out here, quick. Alpha y equals enter. Top, I'm going to do 10 factorial. Bottom, I'm going to do 2 factorial. Times 3 factorial. Times 2 factorial. 151, 151, 200. basketball. Only 5% of male high school basketball players go on to play basketball in college. 8% go on to play basketball in college. Only 5% of male high school basketball players go on to play basketball in college. 8% go on to play basketball in college. I said, what is that? That doesn't make any sense. Oh, baseball. My fault. I'm sorry, my eyes are crossing out. 8% go on to play baseball in college, and 10% go on to play football in college. Only 4% of college basketball players go on to have a professional career, while only 3% of baseball players go on to have a professional career, and 5% of college football players go on to have a professional career. Using a tree diagram, what is the probability that a male high school athlete who plays basketball, baseball, or football will go on to have a professional career? So we have, I'll use the lines here, we have probability of being a basketball player in college, a baseball player in college, and a football player in college. So this is going to be, we'll say, BK for basketball, BS for baseball, and F for football. Chance of being a basketball player is 5%, 0.05. Chance of being a baseball player is 0.8%, or 8%, 0.08. And football player is 0.1. So of those, of all the college basketball players, what percent go to professional careers? So we'll do this. Should know my lines first. 4% become professionals, which means 96 do not. Do all these lines. So I have boom, 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 boom. 3% of college baseball players, so this is going to be 0.03 and 0.97, and 5%, 0.05. And 0.95. So to get the final probabilities of being a professional, we have to multiply. So this is going to be, let me label this better. This is pro, not pro, not pro, not. So to get the final probabilities, we're going to take 0.05 times 0.024, 0.04. This out here. 0.05 times 0.04. This is 0.002. It just wants the probability that a male high school athlete who plays basketball, baseball, or football will go on. So we only need to find the pros. Then we'll do 0.08 times 0.03. That's this, 0.0024. And football, 0.10 times 0.05, 0.005. Add these guys up. This plus this plus this. 0.0094. Hopefully I read that right. Okay.